Okay, so currently we're going through the architecture of the application and ultimately how we want to connect and contribute in the same space. So what we have is something called Vuex. Now this, in non-technical terms, is basically like a database. It's an object store. All of the major parts of the application, all of the artboards, the whole document that you can see here, this whole document is one giant object, and in that object we have nested objects, and you'll see how this all flows out. So that's not really of any interest, and it's nothing new to applications. You have one object that's the application state. And you can see here we have the state, so the state of the application, the current residing state with all of its data so that we can provide this to the application. Think of it like the database to Facebook. The database is the application state and the information goes into the user interface. Now, first of all, a user is singular. We only have one user on this particular interface. Now, you can have multiple users connecting to the same document, editing artboards, but for me, on this laptop, only one person is going to be working on this laptop. Only one person will be working on an Xbox controller or even a VR thing. You can't share a VR headset or an Xbox or anything else. I mean, technically with an Xbox you could. But when we have a user in the space, we are focusing on elements. Now, you can either focus on one element or you can focus on multiple elements. And according to what the user has selected, it will update the interface. So for example, we're in artboard, you select an artboard. If you go inside of a graphical user interface, now we're inside the graphics. If you go, for example, to audio, then you can then go into the audio space as well. And now when you click, you'll notice that it changes to audio. So depending on what the user is focused on, if it's a single selection or multiple selection, this panel and potentially this interface changes completely in some cases. Very good. Next up, we have the document itself. The document is the entire thing. So the document is in fact the entire thing with all of the artboards. Inside of the document, you have connections. So each object is a person connected to the document. We've got John, Joanne, and Jamie. So we have John, this is an example object, and we have privileges. Again, you may not want everybody editing all parts of the document. For example, if you have a graphic designer, you don't want really a graphic designer to go in and start changing the database. So we have privileges. You can read from certain artboards and data types, and you can write as well. And you can also set permissions for individual users on each individual artboard, for example, each individual artboard, or each individual database, code project, or spreadsheet. Again, can be easily resembled here. Instead of artboards, just change that name to spreadsheet, database, so forth. There are the permissions. Artboards. Well, we know what artboards are. It's what the entire connectivity of the application is itself. And what that is very unique in the way that it connects the data. But an artboard right here, we can have many. So it says artboards. It's an array of artboards. So we have, for example, the ID, so we can identify the artboard, the name. The name will appear just below the artboard. So the name will appear below it. So this could be, my first artboard. Then you can have the grouping. Now you'll notice that you can group artboards together. It's kind of sensible because artboards are so flexible and they're in different spaces. So we have the ability to create our own group, just name it, give it a name, and the program will group the strings together, group the names together. So if it finds another group with the name, then it's going to group all of those artboards together dynamically. Next up, you have thumbnails. Each artboard needs a thumbnail to preview it. And that thumbnail is used in the main view, and it's also used in the presentational view as well. Even though we haven't put the thumbnails in here, that's where they'll reside, in those blank canvases. Slideshow position. So any one of these artboards that you see here can be presented in a slideshow. You can see my artboards, website pages, website art, even databases, everything can be displayed as a slide. So what we're going to allow is simply a property that allows you to drag and drop onto the slide thread, and that gives you the position. So this artboard is position 0, this is position 2, and so forth. So let's say we go all the way down, this is position 20. So this is where our artboard will appear in the slideshow. Next up we have history. Now to give this some backstory, history, what we want to do is be able to step through history in a very unique way. We want to be able to step through the history on a specific object, but then also step through the entire document history at the same time. So what we're doing with the architecture is that we are mapping it to the layers. Now layers are going to be flat mapped, and I'll get into the reason why in just a second, but layer 0, for example, has a history, and each object here is each modification. So for example, layer 1 is going to be a text layer, and I edit the text again, and then I edit the text again. So what this array is doing is it's mapping each history object to the layer. Now you also need another array for the history of the entire document, because don't forget, you could have edited this layer 1, for example, first, so you've edited it, and then maybe you changed layer 2.3, you've changed layer 2.3, and of course, the order is different now. So you've got a document history, so you can step back in the document history, but also step back on the history of each individual particular object. And what's also nice is if you look at Time Machine, we'll have it something like this on the canvas, where let's say you've got a text box or you've got database information. You go into the kind of Time Machine interface where you can step forwards and backwards, and like arrow as well. So you can see that what you can do is go backwards and forwards. Obviously I haven't got anything in Time Machine, but you can step backwards and forwards on the canvas. If you can imagine this folder here is a text box, you can go backwards and forwards, look at the effects that have been applied, step through its history and step forward through its history without affecting the overall document history. So it's kind of revolutionary in the way that it works, and it will look really good on the canvas, and it finally gives a purpose to Aerospace. We all know that Aerospace was terrible for changing, between windows, but in terms of actually looking and stepping back through histories, it's rather a good interface, and nobody can patent that sort of design because, let's face it, it's not unique. So we have document history. We have connected. This is the user object showing who is connected to the artboard, which I believe, have I actually shown? Okay, so what you need to remember is we haven't got a complete user interface. We do have a connections object over here. So the connections object for the document is here. This shows everybody connected to the document. However, you can go into a canvas or a video project. Again, video is an artboard, and you can see who's specifically connected to this artboard, who is editing on this artboard. So what you're doing here is you've got the artboard object, and the artboard object has a connected array, and each object represents, for example, there'll be 3 objects, John, Joanne, and Jamie. And again, they'd have the privileges to say whether they are allowed to read and write on this artboard. But this connected array allows us to identify which users are connected to this specific space within the document, this specific artboard in the document, who's connected to this one. Because don't forget, you've got lots of people connected to the document, and they can go out, they can edit. One can be editing one artboard, another one can edit a spreadsheet, another one can be editing the database. So we need to see who's connecting where. Next up, we also have layers. Now, we will first demonstrate what flat mapping is. Flat mapping is stopping this whole nesting business, and you may think that that's silly or a stupid idea, but it's not. Flat mapping is a very, very efficient way of storing data. That's because you've got one level, one object level, and iterating over its keys means no recursion. Recursion means when you go inside of one another. So the problem with nesting is like this. If I was to basically show you, if you got nesting all inside of one, it makes it very difficult to try and find, track and sort data. It becomes very complicated and it's not good. Flat mapping just means that the key is the part that holds its nesting, and I will demonstrate this to you in just a second. Now, zero is very special. The zero layer is where the application can put in like header and footer information on the artboard. It can put in certain pieces of information like the page number and so forth that can be programmatically created. So zero is a special space for the application to do logic. Zero cannot be used by the user. The user can input data into zero, but it cannot, under any circumstances, edit layer zero. There is no layer zero for the user. So their layers palette will look empty if it's just got layer zero. Then you've also got 1, and then you've got 2.0 and so forth. Now let's actually look at the nesting first of all. Let's look at flat mapping and how useful it really is. And then just talk about some of the benefits of doing that, which obviously it's fast. It makes it easily mappable to a database, which is what is coming next. So easily mappable to a database. And also, what's really great about flat mapping is you're not using so much battery power. You think about it, if you have objects inside of objects inside of objects, this is why the DOM is very slow. Excuse me as I burp. The DOM is very slow because it's got objects inside of objects inside of objects inside of objects. And it gets very hefty and very, very heavy. So flat mapping kind of solves that heavy nesting problem, which absorbs a lot of battery power. We're trying to do like green programming in this, where we're trying to use as little power as possible. And whatever architecture we run this on, we want it to run well. So just because we have more power doesn't mean we should use more power. So for example, look at this layer structure. You have, you've got your layer 1, that's just 1. Again, your layers will have names, but we're looking at the actual mapping structure. You've got layer 2, and then finally you've got layer 3. So layer 3 is on its own there. And now we're at layer 4, and we're starting to get some interesting things. So a layer can have the root level number. Now, every time there is a folder, a group, there will be a folder, then you get the dot. Now, I want you to think of the dot like the file system. You know when you go to home/user/, every time you see that /, you know you're going into a directory. So that's what happens. You have a number of elements in a file, in a level, and then you have the dot, which goes in one. And then you can have lots of levels. And then if you get another dot, you go in one and dot. And just think of the dots as /. And that's what flat mapping is. If you actually look at the field URL and look at the field of the actual operating system, what it outputs in the Finder window or whatever type of file explorer you have, it's flat mapping the directory. Well, we should be able to do the same thing again in this. So for 0.0, every time you see 0.0, so notice, just note the pattern. 0.0, it's a group. 0.0, it's a group. 0.0, it's a group. Now when I actually demonstrate this to you in an application, you can finally understand this. 4.0 is a group type object. Because once we have that 0.0, again, 0 is a very special thing in flat mapping, and in this particular case. So what we want to do is go ahead and say add in a group. I'm going to let me delete that out. I'm going to move that up. So now we have 4.0. Then I'm going to add a new layer. Now that's 4.1. Then we add a new layer. That's going to be 4.2.0. Now we've seen a 0.0. Is that what we want? No, it isn't what we want. We want to get rid of that because the next one is 4.2.0. So let's go ahead and add that in. That's a group. So add a group, and I want that to go above sorry about this, it's just not a very clever interface. 4.2.0. So there is a group, 4.2.0, and we've got 2 layers inside of there. And you can just take a look at this, add a new layer. We've got 4.2.1, add a new layer. 4.2.2, like so. And then when you take a look at this, you want to say, there's another 0.0 here, which is 4.2.20. And in fact, that is incorrect. I'm so sorry. Let me just very quickly edit this, just so that it's not a pile of junk. So I'm going to copy that, and then we're going to go back. I need to make sure that everything is right as I go through this with you. So if I move that out of the group, now we've got 4.2, yes, 0.3. So now we're on the next level down, 0.0. Again, we're seeing a point there, so we've gone in another level. And then you can add a new layer, and this goes to now 4.2.1. And that's it. So every time you see 0.0, you're seeing a group on every level, and you can track it back all the way to the root. So we're on the 4th level, 4. We're on the 2nd level, 0.2, 4.2, 0.3. We're on the 3rd level, 4.2.3. We're on the 3rd element in the next object. And then finally, we're in the 1st layer of the object we have here. So we're in the 4th group. Then we're in the 2nd group, 1, 2. Then you're in the 3rd group, 1, 2, 3. And then finally, you have your layer. So this is what flat mapping is. When you actually look at the file URL, again, just change the dots for forward slashes. I mean, technically you could do that, but I like using the dots because it makes it rather clean. But you can have the forward slashes. And so you can have an infinite amount of numbers in each one. So once you get the .0 after the group .0, then you will have as many layers as you want, up to 20,000 or whatever. But the next time you see 0.0, it goes into a group and it goes in further. And if you think about it mathematically, it makes sense. So for right now, you've got the 3rd layer. So if I take a look at this, 4.2.3.0, so 4.2.3.0. So we're here. This right here, this group is here. Now let's say I add in a new layer below it. What will that be? It's got to be on the same level, but it's not in the group. It's just the next one in that group. So what would that be? Well, that would be 4.2, which we're on that level, and then we're 0.4. Now, mathematically, that makes sense because when you go to sort this, you can see that this right here, 4.2.3, is less than 4.2.4 because that 4 is higher than the 3, and anything inside of it, it's always going to be lesser than 0.4. So what happens is that with this flat mapping, it allows easy scalability, it allows incredibly fast for looping with no recursions, and it allows very quick mapping to a database. Everything you should try and do is try to get the data flat. In architecture, flatter is better only sometimes. When it comes to components, you sort of decouple them. But when it comes to things like array data, we try to do as much as we can. And I don't think most software is doing that today. I think that they're being very power hungry with their consumption of power because of all these memory addresses. And I also think that it doesn't make for a lightweight application. So it becomes rather stiff. Okay, So now what we need to do is look at the layer structure. So we've understood layers, we've understood how that works. Again, if it's boggled your mind, I know it can, but again, just think about the folder structure on your desktop and then it kind of clicks and you can kind of see what you're doing. And instead of folder names, you've just got numbers, ID numbers. Okay, so we've gone over the history, document history, who's connected to this specific artboard, and then we've got layers, and we've sort of got this. We will have a sorting algorithm, or potentially what we'll be doing is regexing keys as well if we wanted to. So if we want to get all the layers within a group, we will be able to. And so 0 is the special computed layer. That's for like header and footer, you know, like in Word where you can have header and footer and it repeats over pages. That's where that type of computational data will reside. Then you have layer 1. Now you can have either text, a 3D object or a 3D scene, audio visualization. So you know when somebody's talking, you can see a 3D ball, you can see glowing, you can see all sorts of visual effects. Vector, video, image, code project, database.
Reminders for Loz.
Fantastic, thank you Google Home. Code project, database, which you can also have a database visualizer as well. So you can have database text, for example, or value. And then also you can have database visualizer so that you can put the data into, let's say, you can copy the data from a database and it can be text, or you can copy the data from the database and paste it in. It doesn't have to be a spreadsheet, it could be a database as well. You paste it in and you tell it to make a 3D chart or a chart of some kind. Or you can put it into your Code Canvas projects and you can sort of show hot mapping, source mapping of data and how data is being interacted with the server. Really clever stuff, and it can happen, folks. It can happen. So you have all of these types, and we'll go through each one so that nobody's confused about what we're trying to do here. So we're on layer 2, and layer 2, we've got a 0.0, so we know this is a group. I'm grouping all of these together. This decimal ends in 0, so it's a group. As it's a group, you need to provide a group name. You must provide a group name, or a layer name, if you will. I mean, you don't technically have to, but who wouldn't? You can have masks specifically applied to this group set, and you can have filters applied to this group set. Now, here's what's really special. There will not be a limitation on masks and so forth. People will be able to do what they want and do what they want efficiently. You can have multiple masks, hence the array. It can be vector, bitmap, 3D objects even. You can actually mask with 3D objects in the 3D environment. So you should be able to use 3D objects as masks as well. Again, not something you see in your typical bit of software. You'll see it in 3D software, but it's not in the standard art canvas type thing. And it should be. It should be. You can do lots of interesting effects. We can also add in filters. Filters are 100% non-destructive WebGL filters. WebGL filters are very fast and can be applied at runtime. So what we do is we keep the original image and we keep the filter data and the mask data and everything else, and we apply the filters at runtime. Every time we open up, we reapply all the filters across all of it. Now we can do a bit of caching on that if we want to make it a bit quicker, but WebGL is incredibly fast to the point where it's applying filters in less than half a second to less than that. So yes, in big documents potentially, but overall, no. Now we have our group, when it can have its masks and filters. And something also very revolutionary in what I want to do is to have masks on the filters. Now, when you think about a filter, for example, a filter can change the color, then you should also be able to say where that filter is applied, or even the blur should be applied. So filters also will have masks. It will be easily demonstrated when I make the user interface, but I'm not finished yet. 2.1. Okay, so we have a text element, and the text element needs text. You can set the width and height. The columns are, you know, how many columns you need stacking against each other. You've got the spacing between the columns. You've got line heights, and you've also got letter spacing and all the other crap. I mean, I don't have to demonstrate every typography feature in this object, right? You just need to know that the object type is there and what it kind of looks like. And also you will have a clipping mask. So you'll be able to draw lines and have things interact properly. So for example, let's say you have a picture of a car and it's got a shape and you want the text, I mean this is nothing new in publishing software, you want the text to wrap around that shape. Well, that's what that clipping mask will do for text, is it will allow it to make the text flow with multiple columns over that. I know I'm doing a lot of this stuff, but it kind of helps. 2.2, you can have 3D elements. You can have the name of the 3D scene. You can have objects within the 3D scene. You can have multiple objects, but you can also just have an object plopped right there on the artboard. So if this 3D object, I can put it there. You know, if I go into video, let's say, you can kind of see it a little better. You can, you know, if I go to video, there it is. You know, you can take a 3D object and pop it straight on the artboard. And please do remember, video is an artboard as well. So this 3D object, you just slam it on, and there's your artboard. And objects, obviously, each object needs vector data. Ideally, we want to convert to the OBJ format. So each object, you know, you think you've got a rectangle, a cube, and everything else in 3D space. And what we're trying to do with this is we are converting it to the OBJ space or the OBJ format. We can also have audio files. Now there is a very interesting thing which, and we have it here, I'm sorry that I've cut it out, but in the audio you can have audio visualization, not only on the canvas, so you can have it on the canvas like this, like a little audio wave and playing the audio wave, but you can also have it as 3D space. So you can see here, this guy so you can see how he's got a WebGL project there, and when he's clapping his hands, the microphone is picking it up. Well, you can have the same thing when you're playing audio, and this thing can be dancing around, going crazy on the canvas. And not only that, you can have it in the 3D space. So imagine that orb animating, that's in 3D space. So you should be able to drag and drop from the assets onto the, I mean, you can do it on video, you can do it in anything once you're in 3D space. But let's say we're in 3D space and all your guys are standing around this big orb, and then you start playing some music for the game or something that you want to play, and all of a sudden this orb starts animating, flying particles everywhere, and people are looking at it on their Oculus devices, you know, their 3D headsets, this device here that John's wearing. People can see it in the on the television with the console, they can see it on the phone with a streamed canvas and so forth. Brilliant technology. I mean, this is absolutely A-grade, and it's not actually that difficult to build. Most of the tools and technologies are already out there for Oculus, Xbox, everything. There's nothing unique. What's great about it is the connectivity part of it. And I think that I'm trying to build out a user interface that matches such a quality application. So you've got audio files. You can also have preset names. So again, if you want to visualize something, again, most people won't know how to code a visualizer asset. So this type of asset will be available from the art store, which we haven't got into yet. The art store I will build out, and the user interface will be built out. I'm starting to build out the interface now, and it's very unique. But the artboard itself will have the assets necessary to develop. And people will be able to code their own visualizers, sell them on the art. You can also have a custom preset. Don't forget that you do have the ability to go to the code canvas. So let me go back, or you can go to the code. I mean, again, we can split this view up so you can see the canvas. but you have the chance to view the code. You can view the code right then and there. So custom preset, you can view the code, you can see the code, and you can write your own. You know, you can even copy the preset out, so you have the preset in one space, and then you can copy out the code and modify it if you're a programmer. So we're the artist now. Programmers become the artist. And I think that has a large part in playing with games and things like that. Instead of the background just being like a flat image that's rotating, what about if it's bouncing to the music? What about if it's changing color to the music? What about if it's splattering paint everywhere according to the music? What if you have audio visualization in a presentation, for example, where the canvas, you know, if you think about those beautiful animations of smoke and paint, and that all is bouncing to the music in the background of your slide. Anything's possible, and anything can be integrated anywhere. I mean, again, a video is artboard, so we can have the same thing inside of the video. Damn, I'm good. This is good. And it can be done. Three.js has taken a lot of the hard work, heavy lifting out of it. So much heavy lifting out of it. It's unbelievable. Unbelievable. To quote a famous YouTuber. Okay, so the next up we have the video. Oh, and let's go ahead and make sure we're not skipping over this. We have audio, and again, you can apply non-destructive filters. The filters can have masks on them. You're going so, you know, this really can be even more. I haven't thought of all the ideas yet, but you can have filters. Filters can have masks on them. And you can even have masks on every one of these types of elements. I mean, I don't see why not. It's on an artboard, it's rendered in WebGL, and therefore you should be able to have masks. You can even mask it with another 3D object if you wanted to, or do whatever you want. It's unbelievable. Okay, so next up you have 2.4. You can have vector paths. So the path info for WebGL will be a little bit different, but it's very closely coupled to the SVG path. But if people want to export out an asset with SVG, we'll just keep it in an array. And again, you can have path info. Again, you can have masks and also filters at the same time. The problem is adding filters, people go, oh, you know, why would you want to do that with SVG? SVG does have a subset of filters, but we will allow all filters because our filters are non-destructive. And if they want to export it, then yes, if they want to export it with SVG, it will be limited. It may not look the same, but that's just tough nuggets. You know, we have to stay in the WebGL environment. Video, again, I gave you the 3D demonstration of the video breaking up into 3D cubes and a lot of other things. So it's incredibly useful, you know, having a video as a texture. Again, you will have masks and filters. And those masks can be 3D masks, just like 3D software today. 3D software uses 3D masks, so there's no reason why we shouldn't. So 3D masks, 2D masks, and vector masks. So the rasterized bitmap type masks. And then you've got SVG, which is vector masks, and then you've got 3D objects, which can also be used as masks. Then the next thing is the image. We keep the original image, our filters and masks on non-destructive. Again, fairly standard. You can mask it with 3D, you can mask it with anything, even a video you can mask. I want it to be so flexible that anything can be anything. And it sounds terrible when it comes to programming architecture, but actually in this case, because we've kept it so flat, that this will work very well indeed. And this is the only way it really will work, because otherwise, you know, if you start moving objects inside of objects and something moves and all of a sudden this pointer doesn't work, well, it's terrible. But flat mapping solves the problem. You're just looking at one object. So good. Then we also have code projects. You point to a workspace, just like this here. There's no better demonstration than what I'm currently in, which is VS Code. You point to a workspace. That workspace opens up, you know, the files. It spits out the exported code. Now, don't forget this code has to work with the canvas, so we will sort of show people how to code and demonstrate the code, and people will build on top of that code. And that is, of course, for the coding projects. right here. So you have the code, you got the workspace has all the files in it that you're going to edit and save onto the hard drive, and that will keep that going. However, for the exported code, that is what the canvas uses. So the canvas or the artboard itself will use the output of visualization code, and it will play it right there on the artboard, which is awesome. Then also we have a database, which is absolutely sick. I mean, when you think about what Oracle's database systems can do, I know they're proprietary, but they're in the cloud. I'll explain my views on FSF in just well, not in this video, but in another video. But this will be freedom-based software for anybody to develop and grow. But we could use Postgres, for example. I'm planning to use Postgres until I can get Oracle to potentially let me have a look at its proprietary stuff so that I can integrate with it or Postgres. Again, if you want to know my views, there'll probably be a video, but not right now. Right now I've got way too much stuff to build out before, you know, and I have to get the stuff out before they go and try to copyright it and claim it as their IPO, which it isn't. They suck, all right? We are the first ones with this idea, and that's the beauty of it. We're leaving the idea open for everybody to develop. The schema. Now, the schema is the schema for the database. You've got the connection information. That looks a bit crap. I will fix that, but not right now. But you've got the table itself. The table has the schema. We've got all this information set about the schema. So the schema is just the design of the database. And so you've got the schema is here with database, with tables in the database, and the schema is also the fields in the database. So you kind of do that in spreadsheets. You have your fields and then you have the values below them. Well, that's the same thing here. It's a schema. It's just a design of data. And then also you can view the data as well, which I believe under database, obviously we won't be able to see it, but there will be an object called data, you know, and it doesn't really matter. It's just an object. There'll be a data object. And when the user targets a particular table, because we only have one data view and only one data view open at one time. I don't know whether that will ever change. I don't think it will. So basically, when you're looking at a table, you click on a table, you go into the data of the table, the data object is populated, and this view is updated with the latest table data. Basic. Simple. Very much simple. And next up, you also have the data is the object. Oh, okay, no, wait, I don't know what I'm doing here. Data is the object referencing. Okay, so this appears to be a database visualization. So it's kind of like this, what we did, okay? You've got a database object, and let's say you're pulling out a value. And what's really nice is we can have integrated views, we can do all sorts of things inside menus and everything else, but you have a database value being printed and connected on the artboard. Smash it. From what I can see here, we also have spreadsheets. Spreadsheets are sick, but also you can have databases that can do the same thing. Just because it says spreadsheet here doesn't mean that that's all it can do. You can print out, you can link values from a spreadsheet, just like you've done here. So this text could come from a spreadsheet instead of a database, and it can be linked. This, instead of it being spreadsheet visualization, it's a database visualization. So you copy information out of the database, you organize the information, and it creates a chart, a 3D chart, 2D chart, whatever. SVG chart. And it links the data together, which is what this will allow you to do. So this is called the database visualizer, and that's what was confusing me. I've probably spelled that wrong. But the database visualizer allows you to visually represent the data. You could also have a 3D space that people walk through. With this, so you've got people walking through, and each admin can be standing side by side, one on a console. You know, how cool would that be? Database administration on the Xbox, or, you know, it could happen. I'm not saying it will, but it will be better than, oh, log on to this terminal. You know, and you can look at where things are being hit, and you can look at, you think about it, giant server rooms, you have to be able to track all the terminals. What if you have an entire virtual room, which is what this allows you to do, virtual mapping, and you have an entire virtual room, and you are able to look as an overview of what servers potentially could be attacked. Maybe there's a DDoS attack, maybe there's some other type of attack, and it will be able to identify certain scripts running and certain things happening and file changes, and you go, hold on a minute, that server is red hot. And something is going off there, something's happening, and we have to shut it down, instead of just looking at your boring terminal. That's also an idea, again, and that can be programmed quite easily in Vue.js. It's not difficult, folks. I know this sounds like, wow, this is an incredible feature, but it's not actually that difficult. It just shows you how lazy big corporations have been in the development space or in the creative space. And I want to see the creative space back to us, the creatives. We're the ones that are actually making this happen. Data is the data object referencing all the table information for the visual chart, so forth. So that's data visualization. Then we have spreadsheet. Okay, ignore this because it was very late at night and I've not done very well at this. Spreadsheet visualizer. So for example, you go onto here, you have a spreadsheet, you can have a visual chart. You know, it's just a spreadsheet object. You can have a visual chart like so, a visual chart. Or you could have text from a spreadsheet, maybe in one of these columns you can have text from a spreadsheet. It'll just link it in and just keep it synced up if my camera doesn't keep on weirding out. I don't know why it's doing that. Next up, once you've seen that, so we've got spreadsheets, so spreadsheets again, text or data visualization. Now finally, after talking about everything of most of the architecture, we have artboards, or artflow, sorry, not artboards. Artboards are these guys, all these types of guys, and artflow is when you take your artboards and you put them into basically like a user story or a diagram flow. So what we have is the ability to put artboards in. So we add an artboard, you know, there's a little button up here or somewhere on this pane, add an artboard, you add the artboard you want in, okay? You are clicking and dragging, you position your artboard. You can link elements on the artboard, so certain aspects of the artboard to other artboards. You know, so this element links to this. Okay, that's just like, you know, when you make this link here, once you make that link in Artflow, this happens. Where if you open up the artboard and you click it, you can go, and I clicked on the wrong space. Let's click on this space down here. No, it's got to be somewhere, it's got to be somewhere. Oh no, it's not happening. It's not happening at the minute, folks. I don't know where it is. I don't know. Oh, there you go. Okay, so you've got that. Where once you make that link from this artboard to this artboard, maybe this is a smaller artboard, all you've got to do then is go into that artboard and then simply click it. And then it will take you to the other artboard, like you saw it animate just there. I forgot where it was. I don't know, it's up top. So when you make that link, you'll just click it and then it will go to the other artboard. So that's what FlowFlow allows you to do. And potentially when you click on it, you can also have a flow diagram. So next, you know, if you were to click that link, you may get a question. Admin user, yes, no, appear. So when you click the link, that question appears with yes and no, and depending on what you say, yes or no, once you've clicked the link on this next artboard, you'll get a yes or no button. You'll click yes and it'll take you down to this database. It'll let you view a database. Or if you say no, it's going to go to a spreadsheet or a different artboard. If you say I don't know, then potentially you'll go down the middle and you'll go to a code project, or you will go to a slide. You just say next. You know, like next and forward, next and back in the browser. So you go through the pages. If they're just linked, you know, not if you click this element, it goes to this artboard. Instead, it's, you know, you can have next and back buttons. You can have questions. You can also have notes that appear. So not only are you mapping everything out with Artflow, you're allowing it to be connected together so you can click through the document and go through the user story. But not only that, you're allowing at a certain point, let's say I click on this artboard. Okay, I'm going to click on that artboard right there. And then a question appears. So ignore everything else. Ignore all that stuff. You know, let's just scale this right down just to see what I can do. Okay. So now when I click on that artboard, I click there, you see, oh, that appears from Artflow. Or admin user, click yes, click no, and then it will open up the relevant piece of data or artboard that you've got. Again, there's many more ideas that I have. I simply just do not have the time to demonstrate everything in the UI. I literally would be having a full-time job if I did. So that's also a fantastic idea in Artflow, and you heard it here first. Attached files. So we know that not everything can be displayed in an artboard very fashionably. So inside of here you have attached files. And attached files can be video. Again, they are artboards, but in their own right, they're kind of attached files. They can be used as textures on another artboard. So that is an artboard, but it's also sort of an attached file. It's an environment in which is needed. Audio is definitely an attached file. Audio is not obviously visual, but we are making it visual with the visual representation. The database with the data on the canvas, and you also have coding as well, and you also have spreadsheets. And again, all of those things are just objects. That object, you know, allows you to see who's connected to the coding project, who's connected to the database projects, who's connected to the spreadsheet projects, so forth. And you know, you've got assets in each one of these. Potentially assets could be audio, different types of audio files, different types of video files. Assets, even in spreadsheets, you can have images and stuff inside a spreadsheet, so they may well have assets. Coding projects, that's all on the file system. There'll be a workspace, a folder on the file system, and that's where people work. And so that is that. We again have audio, we want to see who's connected. It's basically following the same model. This is not very complicated at all. But the only thing is, the difference is that artboards have that layer and have that flat mapping, whereas your typical attached files will not be flat mapped. One of the major reasons why that is because they don't need to be. Okay, they don't need to be. They're relatively flat in and of themselves. A spreadsheet is extremely flat. Even a database is fairly flat. Each environment is flat. You know, if you go into database management, you have a view that shows you in plain view, in flatness almost, all of the tables inside the database. You can have a relational view where you can see all the tables linking together and how they relate, but ultimately everything is rather flat. It's when it comes to an artboard that's really special, and what's special about this application is everything connects in that very special way. So it's something that you must flat map to keep it simple. Stop watching thousands of objects, just watch one object and keep the mapping. So you got all these tables as well, all of these tables, and it's all really great. Again, all of this is pretty flat, so we don't really need to flat map this type of information. You know, there's an object for connection, there's an object for table schema, there's an object for data. So we make an SQL query, we pull in the data, we display the data in that one view. And literally it's just one object, one object, one object. It doesn't have to be more complicated than that. Never make it more complicated than that, because your application will suck if you do, and your architecture will be very complicated when you start getting deeply nested. I almost look at it like you're on the motorway and you're always trying to stay over to the left or to the right, depending on which country you live in, but you're trying to stay away from the middle part of the road. You're trying to stay at the edge of the road. That's what we're trying to do. We're not trying to overtake ourselves with deep nesting. I've done it before in other applications and I realized it was just a bag of rubbish. So now this has to be much better. And this works. And what's great about flat mapping is when you connect to a database, when you connect, all you have to do is have the key. you just have the key, so 2.0.3, you get that key and you say update that object. So the efficiency of this increases with the connectivity, and it's on socket technology, obviously. Who wouldn't? Postgres has sockets built in. We use sockets, we transmit objects, and those objects have an ID. So for example, let's say John has just moved a text field. So what I want to do is, look at this object, is move this. So it says, okay, John, so user John ID, so that targets the key that we want, which is 2.1. And then let's say he's moved let's say he's changed the width. So the width is now 200 pixels. And we can track the history. We can see who the history belongs to with the history object. But we can also just target that key very specifically, just once. Just there. And it won't be complicated. There's no deep nesting. Access this object, and then access that object, and then access that one. And what if somebody moves something? And what about locking the whole thing down? Well, I can just lock a key. I can go, John ID is now editing. So I can say editing, and I can set that to true. Now in my flat map, it receives it. It says, right, user John right here on this headset. John's connected to this artboard. He wants to edit layer 2.1, that's the ID, 2.1, and he's editing it. So now everybody's locked out from, let's say, editing this text right here. So this text is being edited by John. You're not allowed to edit it while John is doing it. Otherwise, it'll be a complete faff if everybody can just edit like crazy. So what we want to do is kind of keep the editing lockable, so that once somebody's finished with it, it will unlock after a certain amount of time, or it will just lock people out until that person is finished editing. And if somebody's accidentally left their device on and somehow it just stays locked, after a certain time, all of the basically after a certain time, if the device is left on, if the device becomes unresponsive, then immediately that element becomes available to the creative space. And also document admins, there will be like admins, people with admin privileges. They can easily kick people off and just say, no, you're not part of this project anymore. You're not allowed to be here on this document or this artboard because you're not doing a very good job of editing it. There is the architecture. It is absolutely great to see. It's coming together, and that's one of the major things, is I can see how this will work, and it will definitely work. The flat mapping was the hardest part to this application. The flat mapping was the bit where if it worked, and it has, because let's face it, it already does work with your operating system, home/user, that's just a flat map of the location, and we just have that editing. We just have it clean and simple. We're just watching one object. We are not wasting energy in devices. We're not, we're being green in programming, but also it leads to better architecture. Flatter is better when it comes to wanting to connect elements. Now, if you have a web, again, there's so many things to this application. I might have left out a few things. If you have a web component, so this is a web component. When it comes to web components, they're decoupled. We kind of want web components to be quite unique and quite in the web space. So decoupling is everything there. So what we're trying to do is make everything modular, but also fit together in one simple space, addressable very quickly and very efficiently. And to go over this, when you open up a document, it's not just about making it simple to access and communicate just over sockets. When you open the document, you've only got one for loop that loops over the entire document, that is able to render the entire document within seconds. So that's the type of application that we want to build, and we'll only get there with flat mapping, sorting, and developing. So good architecture will lead to eventually a lot simpler workflow when we want to actually connect things. I'm not having to watch deeply nested objects. That would just be a nightmare. It's rather stupid, and I've done it before, and I will never do it again. So thank you very much. I'm very glad. In terms of the filters and so forth, we're going to use the functional paradigm. We want to go back to like the Lisp days where things were functional and things kicked ass, and Smalltalk as well. Those things were rather good technologies, and their architectures were ahead of their time because we're now going back into their sort of architecture now. So thank you very much. I hope that you've enjoyed this video. The architecture will be available on GitHub. Again, it's under my name, Modcat. If you search for GitHub Modcat, M-O-D-CAT, there will be a project called Blank Canvas. If there's nothing in there, please bear with me. I've just got so much stuff to do in terms of legality, documentation, and making sure everything's correct that we don't basically get some big corporation. They'll probably try to sue us, but unfortunately for them, they won't be very successful because we've already documented it, released it in the public space before them. And the idea is ours. So if anybody says, you're just copying such and such, I say, no, they've just got a bigger media budget. We were the ones that came out with it first, and we developed it first in a basic way. And it's just because they have more resources, but eventually people will come into the project. That is flat mapping.